Hello everybody, my name is Zoltán Kovács. Today I would like to show you some new improvements in an experimental version of GeoGebra. Unfortunately, at this time I need to give a lecture for my students, so this is a recorded talk. I think everybody knows this very simple example. If you have an inequality like y is less than x squared, then GeoGebra plots a beautiful graph. And if you add some other requirements, for example, x is greater or equal to y to the third plus or minus 1, then we have a really beautiful plot. So this is working very well in GeoGebra. But if you do some changes, for example, if you do it a bit differently, I would say this example, and let's say x is greater than y cube plus x squared, then it doesn't work anymore. So what is the reason here? Well, the second part, the second inequality, is too difficult for GeoGebra at the moment, so you have no chance if you want to plot it. Well, there are some workarounds, of course. If you write just x equals to y squared plus x square, so y cubed plus x squared, then you have something working, but it's not anymore possible if you have an inequality. Okay, some other questions. If you have, for example, a very basic equality like, so let's try this one. X cube equals to x squared plus y squared. This looks not very bad, but if you change this to x minus 1 cube and this here also x minus 1 squared plus y minus 1 squared, then you have no idea what happens here at point 1, 1, because if you substitute 1, 1, you will get 0 on both sides. So 1, 1 should be also there. Well, this nice thing is really a great feature of GeoGebra. And let me mention the names who programmed this code. They are Darko Drakulic and Filip Birkelbauer, who did this work in the year 2011. And so it works really for a lot of functions. But not always, unfortunately. Let me show another example, which is something like that. No, the copy was not correct, like that. So this is the so-called tech node curve. The tech node curve is a quartic curve, and you need to see well in the neighborhood of 0, 0, because there are multiple roots here. Okay, let me show what happens if we check the new implementation, the new algorithm. So this is quite similar. Zoom in and let me copy just this. Yes, we have the same, but if I use this new command plot 2D, then we can see that this is how it looks like. So we get actually completely working and accurate curve. Well, the zooming is not so quick in the web version, but it's okay. So not so slow, but not very fast. Well, it is not just for equalities, but also for inequalities. So if we want to do something like that, it's also possible to to add an inequality, and it is not working in the main GeoGebra version either, or if we want to add some further restrictions, like okay, say yes, like this one. So let's say y is greater or equal than x, then we have something like that. Okay, so full featured. Okay, what is the algorithm in the background? It is the so-called CAD algorithm. It was invented by Collins in 1975, and the first implementations were done, well, in 1984, and then 1991 and 2018 were the biggest steps, the milestones in the implementation. For many classroom situations, it works quite well. Okay, let's try two examples. So the first example is a so-called 4-bar linkage demonstration. And the first example shows that we use the old version. So it's quite quick. The old algorithm, we can reach 30 FPS with the animation, but you can see that the curve is not always very accurate. So this is the old algorithm by Philip and Darko. On the other hand, if we use the new algorithm by using the CAD thing, it's also remarkable. So by dragging the points or dragging the proportion, we have quite good results, but the animation is reported to be a bit slower if you do an accurate benchmark. But it's still quite good, and you can see that the curves are really accurate, and the isolated zeros are also shown, which are not really possible for the old algorithm. So there are 3 zero values here on this x-axis. So this is one example. Yes, by using this demo, we are able to do a similar animation in the web browser. Here we cannot see any FPS numbers, but they are, so the animation is quite smooth. And some words about the implementation. It is via a C++ library that consists of more than 170,000 lines of code. The sizes are quite acceptable, so about 3, 4, 5, 6 megabytes in different implementations, and its maturity is also quite good. Let me talk about the programming and testing team a bit, and finally some disclaimer that we use it and we try it and play with it in this experimental version, but it's not there in GeoGebra yet, so it's a kind of decision of the GeoGebra team to include it, mainly technical reasons or resource reasons, or eventually educational reasons can be in the background. But anyway, it's there, you can try it, and if you want to give us some feedback, so please do that. Thank you for your time and have a nice day.